Boom. All right. Go, Jacob. It's all you.
Cool. So I don't know that I'm really an expert on 3D printing, although I just do it a lot. I don't have a presentation. Was I supposed to have like a PowerPoint? Is that
You don't have to. You don't have to have a PowerPoint.
Okay.
Yeah.
Then for the sake of the since I don't really think I do anything that none of y'all do already. I'm just going to go over what I normally do. So we've got two 3D printers behind me. I don't think I can zoom in or anything. I think everyone or a lot of zone hospitals got the MakerBot something or another a hot sec ago. I have given that away to art therapy so that we don't have to deal with that. And then we have an Ender 3 and a Monoprice Select Plus or something along those lines. They are, your typical i3 clones, like nothing insane. Does anyone do you think talking about the hardware, 3D printing hardware, would be helpful to anyone, or should I just go through the software stuff and using it?
So I know at least Andrew was just saying that he doesn't have a 3D printer yet and is trying to get there. So talking maybe a little bit about benefits of different hardwares that you have found might be helpful. I don't know.
I would also add, if you're gonna, I think a useful thing, because I do have 3D printers, just not at work.
Oh, okay, okay.
Hardware-wise, I think it's important to discuss kind of like what the limitations are in hospitals, because you can't really have open bed as easily as you can have like enclosed or like specific plastics, and what kind of temperature beds you need to match specific plastic. Like all those things are way more important in hospitals.
Cool. Okay. Well, I wish I could scoot my computer closer to the printers. Just scoot the printer closer to the camera. So this is our Monoprice. They make some pretty handy printers. They don't make them themselves. They're like all OEM printers. I personally really like Monoprice printers because they're steel framed and they come ready to go out of the box. And they have at least one model that's enclosed. However, both of our printers here are open bed, which means they don't have an enclosure around them. You could just reach in and touch the hot parts if you wanted. I prefer that direction because it's easier to maintain things. You don't have to reach around inside or disassemble enclosures to get the stuff if it's broken or if there's something jammed down somewhere. But it does mean that you probably can't have it in a patient space. My office is pseudo patient space where it's only one-on-one when there's a patient who's interested in that stuff. And they're typically older, so it's not really a huge risk with having the open bed ones. But anyway, as far as parts of the 3D printer, just for the people who don't know already, this is the spool. That's where the plastic comes from. You buy those. Then there's 3 axes. So the bed here moves forward and backward on this kind of, there's several different ways that 3D printers work, move. But the bed on this one moves forward and backward. So that's the y-axis. The nozzle here moves left to right. That's the x-axis. And then this whole bar and carriage thing moves up and down, making the z-axis. So if you've never heard the typical 3D printer gimmick before, it's like drawing with a hot glue gun where it does a flat drawing and then it moves up a little bit and it draws again on top of that. And it just keeps depositing layers until layer after layer it makes the part. So it moves around a bunch in the x and y axis and then moves up in the z axis just a little bit and then does it again. As far as hardware goes, the extruder is your typical point of failure, where you generally have to disassemble it, take off the nozzle, maybe you replace the nozzle, maybe you clean out the nozzle. So that's where you typically have problems. I only use PLA filament. There are several different kinds of plastics you can use. So for that reason, I don't have a whole lot of issues. Like I'm just using normal plastic, normal, regular, good old-fashioned PLA. It doesn't have any particles in it or anything. But if you use fancier materials, like there's materials with like wood particles or carbon fiber reinforcements, or some of them have like iron particles in them to make it magnetic. So if you use those, it wears on your nozzle more, and it's more likely to clog as well. So that's oh boy, am I frozen?
No, you're good.
Okay, y'all are frozen for me, but it'll be fine. The printers. There's two main ways that the filament gets pushed into the nozzle. You can either have the extruder motor on the extruder carriage, and those are typically slower because there's a lot more mass it has to swing around to get it to print, and that's what the monoprice is here. But then the Ender 3 back there is different because it has a static mounted print extruder motor that pushes the filament through a tube into the extruder, into the nozzle. And so for that reason, it can run faster because the carriage isn't as heavy, so it's a lot faster to move around. They have their pros and cons, and I wouldn't say that one's necessarily better than the other most of the time, except when I can't see my screen anymore.
We can still hear you.
Okay. It kind of just depends. If you're buying for your institution, I would just go for one that's a known, reliable printer, like an Ender 3. Would be a good choice, just on account of the fact that the printers are like very popular and they've been well tested. Another good brand is Prussia, who kind of does like is the only 3D printer company that really like is established and does their own like development. Like a lot of them are just copies of that. But then regarding the MakerBot that everyone got, they're kind of garbanzo. I try to avoid using them whenever possible. That's what we had when I started, and then I brought one in, and then the university gave us one. That's how we got the two that we have now. If one of you guys wants to pay shipping, I will gladly send you a printer, because I've got several in my garage. So that's a fun note. Anyway,
about how many maybe hours per week do you spend with your like doing printing stuff, be it design or working with patients or whatever, just to give people an idea?
So as far as my labor hours, like when I'm actively working on printers, it's probably only like between 4 and 8 typically, because the printer's going to be running when there's stuff to print, which there almost always is. The printers are running, at least one of the printers will be running almost all the time, like 24/7. I'll start one before I leave, and then I'll come in and take that one off and put a new print on it. So if you really get into the printing, your bottleneck is typically not your labor as much as it is the printing capacity, because the prints themselves, depending on the size, will take typically between 2 and like 12 hours, depending on how big it is. And so there's not a limit amount of time from I have plenty of time to do other things, because it's mostly next time I walk in the office and I see it's done, I scrape it off and put the new one on, start the new print. Yeah, while Chrome is all goofy, I'm gonna keep talking about hardware. The printers I have are fairly reliable, but I've kind of accepted some issues with them in the sense that the Ender 3 there, it tends to make parts a little beefier than they should be. And like these are all like fine-tuned things that I just have accepted I'm not going to get fine-tuned. So it makes parts really robust. Like it does a great job at layer lamination. It makes the parts very strong. But it makes them not exactly dimensionally accurate. It has a pretty sizable elephant's foot, which I've accepted as just making sure I get good bed adhesion. So if bed adhesion is like how the initial layer sticks to the bed, and if you have that breaks, if it gets disconnected, then your print's going to fail because the moving bed is no longer going to be able to move the print. So I've accepted that that's just how that one is. And then the monoprice one makes parts really pretty and dimensionally accurate, but they're not it doesn't get great layer lamination because it has an underpowered hot end where the temperature fluctuates based on how much plastic it's pushing through. And so that's kind of a trade-off you have to make. I've got the two printers. I use one if it's just a kid toy that should look pretty, and then I use the other one if it's a part that's going to be load-bearing. So like, for example, we 3D printed IV pull hitches for our power wheels so I could tow the IV pull around, and we printed all those parts on the Ender so that they're very beefy, great layer lamination, which is important because normally you try and print your parts so that the load-bearing directions, if you kind of like think about how the forces on that part are going to happen, they're going to be pulling across the X or the Y axis. You want to avoid it pulling across layer lines, so in the Z axis, because that'll cause it to crack more often. So we deliberately printed it on the better lamination, the Ender, which is hotter and gets great lamination between the layers because one of the parts has to be printed just due to the design and optimizing support interfaces. Getting we had to print it so that there was a force across layer lines. So we made sure to print all those parts on the stronger printer. And then like I've got a camera mounted above our like craft table for our craft time show. And that one was also printed on the Ender because it's a layered load bearing part in the sense that it's holding a camera above someone's head. And so it's not like a heavy camera, but it is a pretty beefy assembly. And so that part I printed it with more robust, and its layer lines are aligned, but they are across the X axis. So it's not a layer line problem so much as like some of the screws go perpendicular to the layers. So I made sure that or parallel to layers. So I didn't want those to split it either. Anyway, that's kind of the printer side of stuff. All of mine are offline, so it's just SD cards to load the files in. Pretty handy. I don't have to mess with any of the Wi-Fi stuff. I tried it on the MakerBot back when I was messing with that, and it wasn't worth the effort. So yeah, and then let's talk about the computer here. I just used a MacBook or an iMac, whatever they're called. That's what I'm talking to you on now, and that's how I design all the parts. And then it's got an SD card slot, and I just put the SD card in. I used Prusa Slicer to take the 3D design and then transform it into the machine code that then I export to the SD card and I put on the printer. So I'll show you that process here in a sec. I might have to restart Chrome though.
Yeah, no worries. Oh, yeah, he left.
And he's gone.
Welcome back.
Sorry, I left. So let me talk about the software we use. We use Tinkercad. So I think I can share my screen, right?
Yeah, it should be the little box with the up arrow.
Cool. I'm just going to share my entire screen. So for a second, you're just going to be seeing yourself. Is that working?
Yeah, we see it.
Cool. So Tinkercad is an excellent CAD software. It's my favorite one. And the reason I say that is because it's in a web browser and it's very kid-friendly. So it's pretty portable. There's also an iPad app. So if I'm working with a kid in the room and they're designing something, like this one is a Cuphead mug cup thing from the game. Kid really into Cuphead, so we made that, and he did it. Like pretty much designed all the things. He needs some pointers on some of the more complicated techniques, but like in general, this is how you go about using it. Like it's literally you can just drag out cubes, and it's powerful in the sense that you can set dimensions, and they're in real world dimensions. So if we're like I can, if I need something, I've got my calipers here. It's a very important tool for 3D printing things for like mechanical interfaces and stuff. I got my calipers. I'll set it to millimeters so that I can be like, oh, the screwdriver shaft is 4.83 millimeters. I typically round up since printers tend to make things a little beefier than they should be. And you know, like you always have to take into account like if something was what am I trying to say here? Like if you expect, if I were making a screwdriver holder, then the shaft of the screwdriver needs to be able to go through the hole. So if it's exactly the right size, then it's not going to really fit. You always have to account for like bearing space. I don't know what the word is for that. Just make the hole a little bit bigger than what's going through it so that it can go through easily. So like a through hole as opposed to a snug hole or something like that. Yeah. So let's say I was making a screwdriver holder. I can just say I want it to be, let's just say I want it this is in millimeters, so 1.5 centimeters thick. The hole that I need, because I measured that, was 4.83. I'm just going to make this a 5 millimeter hole so I can dimension this hole. And so I can just put a hole in this block, just that easy. So I click on them both, select them both, and then hit the group button or Command G. I'm going to go ahead and ungroup them with Command Shift G. And so there's also these grid lines. So I always like, if I need something to be symmetrical, which you almost always do, I can align things on there. And then I can also switch between perspective and oblique view. And I can change what my snap to grid thing is. So I've just changed it to 0.5 millimeter so I can make it snap to 0.5 millimeter. Since it's a 5-inch hole or 5 millimeter hole, I'm just gonna make this 15 as well. So there will be 5 millimeters on either side of that. And then I can, to make it nice and rounded, I'll use a cylinder here, and I can set that to 15 by 15. And then I'll align it on to the end of this block. Then I'll put this in the center of that. I'm going to align this cylinder so it's at the intersection of this line and this grid line. And that way I can make sure that this is also on that grid line. This button up here just moves the camera to be centered on what you selected. And so like, this is probably more like this already is probably more than they intended Tinkercad to be used for. Like most people see it as some blocks and they don't think that you can do a lot with it, but you can do like a lot with it. And then let's see, on the screwdriver, the handle's 22 millimeters. So I just need to make sure that I'm 11 millimeters from the wall plate, whatever I'm doing for that. So Since this is already on the center of that, I'll just make that 12 to round up. And if I group this together, that's like the part the screwdriver will go through. And then if I want some holes for to put screws into the wall or something, I can do that as well. So I'll make it like 5 millimeters thick and line it up at the base of that, and then I can have it stick out a little bit at the top and the bottom. I'm just gonna make it 30, and then I'll drop it by 7.5 so it's even. And then I need a hole for the screw to go through, so I can put this in here, rotate it by 90 degrees. It's a little big for a screw hole, so I'll set it to like 3 by 3, or that's not right. Oh no. This one can be anything I want it to be, but this one should be 3. And so I'll add like a screw hole with this. And so it's great. Tinkercad is fantastic for making shapes like this, where you don't really have organic shapes. You can't really do organic shapes very well in Tinkercad. The best you can do is kind of make a mess out of cylinders and spheres and paraboloids. But see, like just like that, if I group those all together, then I've got that part, which I could screw it into the wall and then just put my little screwdriver through the top. And then to print it, I probably want it in this orientation because of support material. Like 3D printers aren't great at making overhangs, so this minimizes the amount of overhang I need. The only overhang I have in this shape, since this is the bottom is flat and all of these holes are up, with the exception of this one. So that's this hole where the screwdriver would go through is the only overhang I have to deal with. And since it's only 5 millimeters, it's probably going to be fine, just because little overhangs, like where it's like an arch, like a hole that's less than like a centimeter, I just leave it. I would print this with no support material, and then if I really need to, I'll just run a drill bit through there, and that'll let me, that'll just make the hole circular again, and then it'll be good to go. So, you know, if you think about what your tolerances are important and where they're not, and like what is an okay amount of error, then you can kind of plan efficiencies into your workflow. So like that, I'm not going to put support material. That'll make it way easier to process at the end because I won't have to break it off. A lot of times I get support material that's just permanently attached. So I'm just going to not do support material and then just deal with a hole that's slightly not circular. And so, yeah, that's like how I design parts for like mechanical things, or like if I needed to build a hinge for a door, or I made a latch for our playhouse outside because the latch that was there wasn't kid-friendly enough. But if I needed to do a latch or a hinge, I'd probably just use something like this, and then another one that's more like a C shape that goes around there, and then put a bolt through it. Like you can make, if you can just imagine the shape that you want, then you can CAD it really easily. I'm going to show you some examples of things kids have made, because they don't. I typically try and get kids not to make complicated shapes. Just do like static objects, like, you know, like Cuphead here. He doesn't have any mechanical complexity. Like there's no hinges or loops that are like chain loops or anything like that. Like it's one part that doesn't have to move relative to itself. So like that's a really easy thing that he made. This house was not a kid. That was just me demonstrating how to do stuff. Edward, the same Edward, also made this character just out of spheres and stuff. I'm going to open that one. And then like, you know, here's a Berlin heart model. So like, it's just like, it's not, it is a kind of organic shape, but I approximated using cones and stuff, cones and hemispheres to make it kind of rounded. And then somewhere in here should be like Ava's car or something. This is another kit design. It's like a robot-looking character. And then we've also got, we did custom Hot Wheels a while ago. So we had some kids design a car that then I just kind of attached to a Hot Wheels chassis. So I've got a few of them here. This one was a patient who wanted a Dodge Challenger. So we went to Thingiverse, which is another website I should probably talk about, where you can just download a file. So we found a Dodge Challenger Hellcat or whatever, and we found the logo, and then we kind of modified it using these cutout pieces to make it fit. And then this one, a kid made completely by themselves, like not from a model. They, put some cubes in. They cut some chamfers, some angles into it to make it a little more aerodynamic. It's not perfectly symmetrical, but that's fine. And so they did that, and they put their name on it. Very fun stuff. And so like that's the kind of stuff that I have kids do a lot, is like they'll make some basic, like a static thing that either will just fit onto something that's existing, like customize a Hot Wheels car, or also do like just a character. So like this kid, we made a paraboloid body, and I'll put this work plane away. And like he put all the little guys, and like these are just spheres that have been stretched to oblivion. And so like you can really make all kinds of fun shapes. It's pretty, like, kids understand blocks like intuitively. And this is just like blocks, but they can intersect. So like you just drag out stuff. The hardest part for most kids to get a hang of is how their 3D print, like not how the 3D printer, but how the like basically that they're working in 3D space as opposed to 2D space. Some kids just get it. Some kids have a hard time with that, where they'll try and they'll draw it basically in 2D, and then when they rotate it, it's like completely not what they thought it was, because it's not 2D. Like all the different things are at different depths. But Edward here really got into it. But let me show you how you then go and process one of these files to print. I use the Prussia slicer, which is super handy. And I'm going to go ahead and export. So you can export the file. STL is basically the standard. It's like stereolithography or something. And so now if I go to downloads, it'll be there. And so there's the 3D file. And then I can add more of them and range if I print several. But I'd probably only need one. So I'll just leave it at one and not twice. And that takes our 3D file and it turns it into a bunch of these little guys, layers. You can see if we zoom in, like it's cylinders. Like that is exactly the way that it's going to lay out the plastic. And so we can go through and we can look at that. If I was printing like a sign or something, you can also have it stop at certain layers to be a different color. So now if I see this, it's going to print the yellow parts, and then the printer is going to pause and wait for me to change the filament, and then it'll continue printing in the second color. So if you have a sign, like if I put in, I think I can just put in sign here. Like this Fortnite sign, it's at 2 layers. So like the base plate there is yellow, and then they did the text in black. So if I download this file, I can just put it in there. And then if I hit slice now, it'll say it recognized that it was a sign. So I can even just hit that button and have it do the top 3 layers. It recognized it was a sign, so I can have it do that automatically. And let's talk about settings here too. So right now it's printed with what's called a raft, I think. I don't want a raft for this particular one since it's just big and flat. I had the raft turned on because I was printing something that was narrow and tall, and I needed a bigger foot for it to stick to the base plate. So if I hit slice now, you'll see that it's just the thingamajig we were talking about, and I can do the same thing and make our sign different colors. So now it'll print the yellow part, and then it'll pause, and then it'll hit the green part. And then once it's sliced, I can hit export. And then I normally would I'll stick the SD card in the back and select the SD card here from devices. But I'll put it in download so I can just name it. I always use a standard naming conventions to make it easier to refine parts from a project if like a specialist lets me know that a kid lost something, or if it's like an educational piece and I lose one of the pieces. Like I did a whole like organ thing, like all the organs in a little plastic body. And so if they lost their kidney, I can 3D print a new kidney. I can find it later. So I come up with a 4-letter acronym. Like right now, I have a kid. His name is Aaron. He wants this modular mounting system for his like headphones and stuff. So I'd call it like AMMS for Aaron's modular mounting system. And then I try and put in what it is and kind of shorten it a little bit. So if it's like the phone headphone holder, I'd be like HED for head, phone, and HLDR. So I'm not using any spaces, and I'm capitalizing the first of each word. And then if I'm printing several, I'll put like X2, or maybe if it's the second version, I'll put like version 4, version 2. So that way I can read it pretty easily on the machine if I'm selecting what I want to print, because the machine only has such a big screen and it's limited how many characters it can display. I think it's typically like 15, so this might actually be a little long. So I could just shorten it to headphone HP holder. And no one's actually going to know what that is except for maybe me later. But that's how I organize stuff. Does anyone have any questions? I feel like I'm jumping around a lot.
Andrew, before he had to take off, had a question about your thoughts on plug-and-play printers versus more maintenance-demanding printers, which it sounds like you kind of already talked about with the MakerBot versus what you're using, but I don't know.
Right. I always get the pre-built ones. My first printer was a kit, and that was just a hassle, and it was always getting like loose and falling apart. So nowadays I just get the ones that are like pre-built. They always do a great job of assembling them. If you order it from Prussia, they do that. A lot of them will be like, they're like almost assembled. Like it's like I think this one came flat packed. So like this big loopy thing here was unscrewed from the base, and then I just had to tip it up and screw it in. But I try and do it that way as opposed to kits, because it's less maintenance demanding in that sense. But I always aim for ones that are able to be maintained, because in my experience, like the MakerBot is sold as the streamlined solution, but it is actually a terrible solution. Like it is a pain in the ass it is a pain to maintenance, because like it's all their little proprietary parts. It's way more expensive in the long run. Like it's expensive up front, but it's also like, you have to use their filament or manually rewind it on their spools. So I try to avoid that kind of thing. I try and keep it as much open source as I can, just because there tends to be more of a crossover between other platforms, and so there's lots of documentation, at least vaguely relating to it. And like the MakerBot extruder jams a lot, and then like you don't really have much recourse except to take it apart, but they don't want you to, or to buy a new one, or like I think they have like a swap out thing that they do. So I try to avoid that kind of stuff just to keep it accessible. A lot like Prussia, for example, like all of their stuff is pretty much open source. Like they sell the parts and they're expensive, but you can get generics for all of it because they support their community like that. MakerBot is not that friendly. I don't know. Does that answer the question?
Yeah, I think so. And Brad had a question around for 2-color printing. How soon do you need to start the second color going? He's always worried that the second color layers won't adhere well. Do you have to do it quickly, or can you leave it for a while?
I've not tested it on a load bearing part where I'd be worried about layer adhesion. It always is at least on there for topical use. I don't know. I haven't tried it on something where I haven't printed a piece vertically where then it would be pulled actively apart. But for science and stuff, it works fine. The monoprice doesn't even support the pause feature, so I only do multicolor printing on the Ender, and the Ender does a good job at that anyway. Generally, I don't think it's so much that the filament below still needs to be warm. It's that the filament coming out will melt a little bit off of the previous layer. So I don't think it makes a huge difference, but I haven't tested it. I don't even worry about it. Sometimes I'll print the first part when I leave, and then I'll come back, and it's probably been done for 6 hours, and I'll continue. I've never had it just not work at all.
Cool. That's good to know. I would love to hear more about the this body part organ thing that you did. That seems very interesting and something that others might be interested in.
Yeah, so on Thingiverse, at least, let me log in here. Thingiverse I hate it and I love it because it's the best repository out there. It's all free to use, but it is also not being actively supported. Apparently, they did just hire 2 more people to work on, they had no one. They just hired 2 people to start working on the website, maintaining it. But MakerBot, since they got bought out by Synersis or whatever, hasn't been taking care of it very well. It's probably in likes.
So I guess, and I'd also be curious, how did that conversation come about? I assume you did it for Child Life.
Right. Yeah. So
how did that work?
I have a pretty robust relationship with Child Life, and they're pretty confident in my ability to do things like that to help them. So I think they heard about I think that the Child Life specialist reached out to me. They had self-identified needing this product, and they asked if I could make it for them, because the store-bought versions are fairly expensive. I can't find it. Let's do organs. This guy, I think, maybe.
I had turned off your sharing, so you'll need to share again.
Right. Entire screen share. Cool. Can you see now?
Yep, we see.
Cool. So that's not it. I know it's on here somewhere, but I don't know if they found the model, or maybe we both sat down and were looking for the model. I don't even know what to look up for this. Abdomen. It's also the search tool on Thingiverse is abysmal. So sometimes it's even better to go through Google to find things on Thingiverse. Um, anyway, we definitely had that.
But so it's
but
an abdomen like
yeah, it's
chassis case, and then all the little bits in there that fit so that they
It's
can.
vaguely like this, and it was just plastic. Obviously, we did different colors for each of the organs. I didn't like not all the colors necessarily correlated well. I think the kidneys were yellow. The heart was red. Obviously, the lungs were like a blue or a white. And so we printed it, and there was a bunch of parts, and then so that was for one of our units, and then another unit saw that they had that, and so they asked if they could get a bunch of hearts, like just the heart model. So I did that, printed a bunch of the hearts. I'm a little disappointed it's not in my collections because I could have sworn I saved that, but I guess not. But then the alternative to Thingiverse is printables. So sometimes the specialists reach out to me, but sometimes I reach out to them. A lot of times it'll be they saw something else that I printed for another unit, and then they ask if they can get something similar. I did do a full spine, and when we labeled all of the bits, all the spine pieces. So what that looked like was on Thingiverse. Spine. Oh boy. Search tool has no spelling correct. So I don't know if it was this one. I don't think it was. We're looking for one with the hips. But we found a model that we liked, and then but it didn't have the what part of the spine each was. So we put all of those into was it Dave who did this? I hope that it was Dave. Boy. But I'm not gonna find it right now probably, but we just brought all of those into Tinkercad, and then we used the text tool to add the text to them. So this is going to take a second to load because Tinkercad's not super friendly with high poly models. But you can see the text there. Those are just the text tool, and then we just put use this tool, which moves the work plane onto another surface to make it easier to add the text, and we added the text. So this is probably going to take a second to load, but that's how I find models and how I typically get requests for that kind of thing, like educational models. Almost all of the time, it's the specialist coming to me. But sometimes if I have an idea that would be cool, I'll go to them too. Does that answer the question? I kind of forget what the question was.
Yeah. Yeah, so they come sometimes with just an idea, or sometimes with an actual picture or a thing that we want this, and then work with you on refining it.
Right. Yeah, and a lot of times it'll be that, and same thing with patients too. We have these little cards that I give out to kids if they get referred to me. It's got on the back it lists video gaming, 3D printing, media production, robots, adaptive devices, medical toys, STEM education, and technology help. It's kind of just like the little calling card for what I do here in the hospital. And they'll sometimes a kid will have found a model. Sometimes they're just interested. Sometimes they'll call me. Sometimes they'll tell a child life specialist, and then they'll call me. But like some kids, like there's this one kid who on TikTok has been finding, I don't know who they're following, but they keep getting these like dragon 3D print files. Like they are just really into dragons and dinosaurs. And so they will approach me for wanting this particular model. And then like I find the model and it's not free. Like it's one of those models you have to pay to download. So after a few of those, I tried directing them somewhere else with that. But sometimes they find it. Sometimes it's just like a kid wants like a headphones holder or something, and then I'll show up with my laptop and look through Thingiverse, pick out some ones to try, and we'll do it that way. Yeah.
Annie had a question that I think you kind of answered, but like when you so Child Life gives a card to the patient, do they call you? How do you know to like go talk to the patient? And do you know at that point when you first talk to the patient that, hey, this one's interested in 3D printing, or is it just sort of you go cold and then you try to suss out like, do they want gaming? Do they want 3D printing? Like what that is?
So it's sometimes a child life specialist will give me a kid's name and room to go visit just in general. We have like a referral sheet that's like an Excel sheet that's shared where specialists will put in things that a lot of times it's just gaming, like a kid wants to game. Or sometimes they need tech help. A lot of times I'll find out about a kid just because like it typically won't even be a child life specialist. It'll just be a nurse who has seen the little card. Maybe they have one at their nurse's station and they see the word tech help and they call. And then I'll go up there and there's a kid there who's into that kind of stuff too. So I'll talk about it while I'm fixing their Xbox, connecting it to the Wi-Fi, that kind of thing. And then it's that, and then if sometimes the child life specialist will just give them a card. We sometimes our technology stuff is generally now centralized, so it's all on a cart just outside my office, like all the Xboxes and iPads and stuff. So if a patient, when the specialist picks that up, they take one of the cards and they leave it with them so the kid knows who to contact if they need help connecting to the Wi-Fi and whatnot. And then the kid will read the card and see that. The patients I see tend to skew older, like 8 to 14 a lot. Older kids are too cool for school, and then younger kids can't read the card, which kind of works out. Like I'll still help those kids if they need tech help, but most of it will go over their heads. And that's not always the case, but like Edward is 8, I think. He's the kid who designed those things. Ava, the dragon kid, she was also 8 or 9. I think she was 9. So like that's the age group that really seems to be involved in that kind of stuff. Interested in that stuff. I've got other kids who are older, but they typically are more down to business when it comes to 3D printing. Like they know what they want and they are they just want it, you know. Anyway, does that answer the question?
Yeah, I think so. I don't know. We're sort of at time. Annie has to run later. Annie. Yeah, cool. Thank you, Jacob. That was great.
Awesome.
Yeah. Let me stop recording.